Thank you for joining me for another episode of Empower Apps. I'm your host, Leo Dion. Today, I am joined by Tim Condon. Hey, Tim, glad to have you back.
Hey, Leo, thanks for having me back. It's great to be here.
So a lot has changed since you came on the show. Geez, I want to say it was at least a year ago. No, it was a year ago, actually. I just looked at it.
It's been a very quick year.
It's been a quick year and kind of a slow year too, but it's been a kind of a bit of a phase. But I want to congrats you to joining the Swift server work group.
Thank you very much.
Yeah. So what exactly does that mean?
So the Swift server working group is a kind of subsection of the Swift.org team, effectively. And the goal of the SSWG is to basically promote everything server-side Swift. So it's pushing forward things in the language, making sure that server-side Swift is considered when doing things like async await, and talking to partners and building up the ecosystem. So a big focus of the SSWG is to make sure that there's an ecosystem for server-side Swift stuff. So growing packages, growing the ecosystem, and making sure that packages built for the ecosystem will work across all the different frameworks that there are out there for server-side Swift.
So like specifically, whatever packages come out will actually be supported on, say, Linux, for instance, which is the vast majority where servers are deployed, right?
Yeah, well, to be honest, most of the packages will be supported anywhere because they're all based like pure Swift. So they only really rely on Foundation, if they rely on Foundation at all. So things like SwiftLog and SwiftNIO, they'll run on Windows, they'll run on Linux, they'll run on Mac. So it's enabling like a bigger ecosystem of packages.
Nice. Yeah. One thing that I think was a big deal this year was just seeing server side make an appearance at WWDC this year, both Vapor and AWS Lambda. There was a whole talk on AWS Lambdas, which is absolutely awesome. And it shows you that like Apple, at least, is willing to recognize and support the server side community when it comes to that.
Yeah, it was really cool. It was obviously having an entire WWDC video and session dedicated on Lambda. It is really cool to see and a great way to get people involved in server-side Swift. And also having a little shout out to Vapor when they were talking about virtualization and running on Linux in the State of the Union was really cool. The Vapor chats really kind of lit up there.
Yeah.
It's a nice little thing to see.
Yeah, and rightfully so. That is pretty awesome. So let's talk a little bit about SwiftNIO, which I think is the biggest component when it comes to server side. For those who don't know, could you kind of explain how SwiftNIO fits into that puzzle?
Sure. So SwiftNIO is a non-blocking event-driven IO framework. And that basically involves doing all the kind of low-level nitty-gritty stuff of building network applications, and for us specifically server-side applications. So whether that's dealing with TCP or UDP, whether that's parsing HTTP packets and sending requests and receiving them. So SwiftNIO kind of handles all of that base logic. And SwiftNIO also has a really strong channel concept. So building channels for different use cases, whether that's SSH or HTTP or testing. And it kind of handles all of this low-level stuff so that frameworks built on top of SwiftNIO don't have to worry about that. So as a Vapor developer, I don't really have to care about how I'm interacting with the kernel, for instance, to receive network traffic. SwiftNIO will take care of all of that for me, which allows the Vapor core team and the Vapor community to build a really nice abstraction on top of that, and really nice opinionated APIs for developing server-side Swift apps. So SwiftNIO is kind of the base of everything in the server-side Swift ecosystem.
Explain to me why, one, if they were going to build a server-side application or any sort of networking application, I should say, why would they want to use SwiftNIO and not just use, say, URL session?
So URL session's kind of fairly legacy. I don't want to say legacy, but it's not designed for server-side applications. URL session is definitely designed for client apps making requests to external APIs. Receiving network traffic is not something that URL session can really do easily, certainly without a lot of hacking. And so you kind of need a way of being able to accept network traffic and HTTP traffic and other kinds of traffic. And so that's what SwiftNIO provides. In the very early days of server-side Swift, before SwiftNIO was a thing, all the different frameworks, whether that was Vapor or Katura or Perfect or Zero, they all had their own implementation of this kind of HTTP library.
Yeah, I remember that.
Yeah. And whilst most of them worked pretty well, it's a lot of effort to kind of create and maintain that. And whereas if we have a kind of central library that's has a dedicated engineering team behind it, it means we can have a really efficient, really well-built package that everyone else can build on top of.
Hey, I want to let you know that BrightDigit has openings for new clients. BrightDigit is my company, and we specialize in development in the Apple and Swift space. We're doing a lot of work helping clients update their apps for iOS 14, macOS Big Sur, and watchOS 7, as well as doing some recent server-side development in Swift with Vapor. Now is a great time to get started updating your apps. If you're interested in having BrightDigit help your team, reach out to me, leo@brightdigit.com, or go to brightdigit.com to learn more about how we can help you get ready for the big updates this October. Thanks again for listening to our show. So I'm going to turn that around and then ask, would you ever use SwiftNIO on a iOS app or any other client-side app?
Yeah, there are definitely use cases for using SwiftNIO. Most of the time, if you need a server to be able to receive connections. So that could be you're building a video player that manages DRM encryption, and you need to be able to decrypt your video on the fly with the DRM keys. So in that use case, you need to be able to spin up a server that can stream the video in the clear locally on device. So you could use SwiftNIO for that kind of use case. Or if you're doing any kind of integration testing, you might want to split up SwiftNIO locally on device, so you're not making external network requests when you're doing integration testing, and that will make things easier. So there are definitely use cases for using it on the client, but it's certainly not the most common requirement, I'd say.
Yeah, that makes total sense. And it's funny you mentioned SSH, because we just saw recently the release of the SwiftNIO SSH package, which is awesome. I think that's going to be really powerful for a lot of developers. So I wanted to talk about your article from earlier this year about the state of server-side Swift and Swift packages.
Yeah.
Well, first of all, I'll just let you kind of explain the article and what was the thought around it.
So the thought around the article was kind of giving a bit of an overview of Swift on the server and looking back on the year before, and looking forward a little bit to 2020. So at the end of 2019 or early 2020, when I wrote this, things were a little uneasy, should we say, in the ecosystem. So IBM had recently announced that they were leaving Swift, and Katora was kind of being handed over as a community project to anyone who wanted to take it. Otherwise, it was basically going to wither and die. And there was a lot of questions around whether Swift on the server was going to be a viable future. So it was kind of counteracting that point and going through all of the things of the previous year that had happened that were specifically focused on Swift on the server. So we had people joining the Swift core team who were responsible for things other than client apps. So Tom Duron, who is basically responsible for SwiftNIO and the Swift Server Working Group. We have Salim, who's almost single-handedly ported Swift to Windows.
Yeah, exactly.
So there was a clear sign from the core team of Swift there, that the Swift core team, that they really wanted Swift to succeed on other platforms. And then it was basically going through all the different things that happened over the year. We had Swift Crypto. We had the announcement of Swift 6 and its goals, which included async await. Then there were more Linux distributions being supported. There was Amazon's Smoke framework was just hit version 2. And there were other things like Swift for TensorFlow and Swift WASM that were starting to emerge that was proving a really exciting time for Swift outside of the Apple ecosystem.
Yeah, and we see the continued expansion of SwiftNIO to other distributions besides Ubuntu. Even the release with Ubuntu 20, that was supported, but also CentOS, which, of course, is in its own strange state right now. But Amazon Linux, so people who don't want to go with the Lambda route can always go with EC2 and use Amazon Linux. We saw that. And then, of course, the big release of Vapor 4 as well. So, yeah, it seems like over the year, things have panned out quite in the positive from when you wrote that article, would you say?
Yeah, definitely. It's every year I take a step back and have a look and talk to different people, and the growth of Swift outside of the Apple ecosystem and on server-side Swift just seems to exponentially grow and get quicker every year. I was just having a look at the swift.org blog page earlier today, and going back from when I wrote the original article, which was kind of early 2020, there seemed to be a period of like 3 or 4 months when the only things being posted on that blog were server-side Swift things. So it was additional Linux distributions. There was the Swift AWS Lambda runtime. There was the Swift Service Lifecycle package, the Swift Cluster Membership package, Swift System, Swift on Windows. There was the Swift Service Discovery. There was SwiftNIO SSH. Just kind of huge, like, avalanche of open source packages from Apple and from the Swift team focusing on the server side, which was fantastic to see.
Yeah, it really is. So a couple of things I wanted to ask about was, speaking of Salim, I wanted to ask, what is the state of server-side Swift on Windows?
So Windows is in a good place, but not perfect place at the moment. So Swift is running on Windows. You can download XE installers. I think they're called XEs these days. It's been a while since I've used Windows.
Yeah, ditto.
To install the Swift runtime on Windows, and it works. Unfortunately, at the moment, there's still a little bit of work to do to get Swift Package Manager working completely on Windows, although I do know that it is mostly working. I know SwiftNIO works on Windows because I've seen all the pull requests to make it work, and Swift Crypto also works on Windows because that was recently merged. So the building blocks and foundations are there, and I suspect over the coming months we'll see Swift Package Manager fully support Swift Windows, at which point any kind of package that's built in Swift, including Vapor, should work. There's a little bit of work for Vapor to do to hook into some of the low-level stuff, which will also enable Vapor to work on iOS and kind of any other platform. But for most part, it's almost there and is almost ready to go.
So would the thought be is like in production, either you install Apache or Nginx, or would it work with like IIS, I guess, since IIS is the big web server? I don't know. It's been a while since I've used Windows, but in the old days it was
same, yes.
Yeah, I mean it was IIS, and then you'd hook up whatever PHP or whatever you want to do node onto IIS. So I was curious about like, is that the thought as far as like if you wanted to serve your Vapor app, you could hook it up to IIS or what?
I don't know is the answer. If IIS can act as a proxy, a reverse proxy, then definitely that's the use case. I guess there's two real use cases for Swift on Windows. The first is developers who have Windows laptops wanting to just build Swift applications before they deploy onto Linux. That's a huge ecosystem out there. And that enables all those developers to actually do that. The second use case is anyone who needs to build a server-side Windows app that has to talk directly to some low-level Windows components. So you do the same on macOS if you need to talk to any of the kind of Mac-specific frameworks like Core Animation or anything like that. You have to deploy onto a Mac. So if you need to talk to any specific Windows frameworks, then you'll deploy onto Windows. And that opens up that avenue as well.
Right. So speaking of Windows, the other concern with Windows is being able to install it on Apple Silicon. And so we have Apple Silicon Macs. I have one, which I'll try not to talk about today because I want to save that for another episode. But as server-side developers, one of the things we need to run into is things like Docker. How will Apple Silicon affect server-side development on these new Macs?
So for the most part, it shouldn't make too much difference, really. I mean, if you're developing on an Apple Silicon Mac or an Intel Mac and deploying your app up to Heroku or AWS or GCP, really shouldn't make a difference to you. And ideally, it won't. And that means everything's working. But I think longer term, it makes a really interesting proposition for people deploying server-side applications, because most people want to deploy onto the same architecture that they develop on, because there may be some low-level differences. So if you're doing things like low-level crypto libraries and talking to assembly language, then there are use cases that are specific to architectures, and you need to be able to test those. So I think being able to develop on Apple Silicon or ARM and deploying onto ARM makes a really, really interesting use case. And we're seeing it with all the different cloud providers starting to announce their own ARM-based servers. So AWS have got their Graviton 2 chip that's much lower cost and higher performance than any of the other chips they have. And as soon as you can deploy into that'll be really good. And any CTO or CFO, if you say to them, deploy your app onto this new architecture. It will compile just as well, but it'll be quicker and cost you half the price. Anyone's going to jump right on that. So I think that's a really interesting thing that we're going to see over the coming months.
Hey folks, I wanted to talk to you again about AppFigures. You probably already know them about their analytics and their App Store optimization. AppFigures really is about giving app makers the tools they need to get more downloads and revenue. Well, now AppFigures can help you track competitors, from how many downloads they're getting and how much money they're making, to their audience demographics and which SDKs they use. Their competitor intelligence really gives you great context. Say a competitor adds like a new feature or was mentioned in the news recently. With AppFigures, you can see if that brought in more downloads right away. Got a great idea for an app or a game? Well, with AppFigures, you can figure out how big that market is and how much money you could be making with it. And that's just scratching the surface. Whether you're growing your app or building a new one, AppFigures has the tools you need that will reduce the risk, but also get you more downloads. You don't need a large budget or a data science degree to do this kind of thing. AppFigures has made it affordable and simple. On top of tools, AppFigures also provides a lot of great guides and tutorials to take you step by step through gaining more visibility with ASO and increasing your revenue by learning from your competitors. They just released a free guide on that, actually. So go ahead, head to the link in the show notes and try AppFigures for free. If you like it, use our special code EMPOWER3030 to get 30% off for the next 3 months. Thank you, AppFigures, for sponsoring our show. Yeah, so I bought a Pi 3 a few months ago because I wanted an ARM server, and it's a super cheap way to get an ARM server. Yep. And yeah, I mean, it works fine with Vapor. Like, there's no problems, none whatsoever. The biggest challenge with the new Apple Silicon, is the fact that I can't run Docker and I can't like test out my Lambda and deploy it. So that's been a challenge, but otherwise, like, development's been totally fine, and you know it works. But yeah, Docker doesn't seem to be working, and I'm trying to avoid installing Rosetta, which is kind of stupid because Rosetta is like amazing, but I'm trying to avoid any sort of emulation when I can. And yeah, Docker just simply needs Rosetta to do anything, even with the previous stuff. Have you looked at the new virtualization framework that Apple put out?
So as far as I understand it, that virtualization framework has actually been out for a couple of years now. I know there are a couple of hypervisors based on top of that have been around. So in my previous company, I was responsible for doing a lot of the CI infrastructure with Macs. We used to virtualize all of our things using a product called Anchor, and that's built on top of the virtualization framework, and that's been around for a while. So I think it's been around for a while, but it probably didn't provide everything that Docker needed, and they had something that worked. So I just think it's taking time to shift over to that.
Yeah, I want to look at it. Sven Schmidt, who will be on the show in a few episodes, runs Swift Package Index, and I know he had a really good article about how to use it. And there's a couple of GitHub projects, but I really want to. It's one of my pet projects is deep diving into that virtualization framework and seeing what you can do as far as like virtualize. But I think in the end, you still end up with the challenge of not being able to build for x86 because I don't think it does architecture emulation. Is that correct?
Yes, you can't emulate other architectures, but there are ways of building for other architectures. So you can cross-compile for an ARM on an Intel machine and cross-compile onto an Intel machine from an ARM machine, the low-level Swift toolchain commands. But you obviously can't run your code unless you run it through an emulator.
Oh, okay. Well, that's good though. But at least you can package, which is nice.
Yeah.
So, do you think there's a big future for ARM-based servers in the cloud? Do you think that's where things are headed?
Yes, I really do.
Okay.
I think the performance that Amazon are kind of showing with their new Graviton 2 chips is phenomenal, frankly. And more importantly, it's a lot cheaper. So if you say to developers and CTOs and especially CFOs, just run your stuff on these different chips, it will compile fine and it will cost you half the price. Everyone's going to jump straight on that.
Yeah, I would say so.
So yeah, and performance-wise as well, it's just as good. I know that AWS, if you choose Elasticache instance, by default it runs on ARM because it's cheaper and more performant. And I suspect we'll start seeing a lot more of that over the coming months and years.
Yeah, and I've had no problems running like other server-side components, like Postgres runs fine on my new MacBook Air and all that. So, yeah, I think that we'll definitely see a lot of movement there, and hopefully we'll see circling back to Windows. Hopefully Microsoft will get Windows to work on Apple Silicon. Whatever legal mumbo jumbo they need to do for that can get going.
Yeah, I suspect it's lawyers mostly at this point.
Right. Yeah, exactly. So the other big thing that came out this year was Vapor 4, and that was pretty cool. We had Tibor on to talk about Vapor 4, and one of the things I really liked about it is how it kind of mimicked the sort of use of property wrappers, especially that SwiftUI brought in onto the server side. And it made, for me, like one of the biggest components just dealing with Fluent and modeling and things like that. Mm-hmm. And it really brought a dynamic component to server-side development. And I found actually the upgrade from Vapor 3 to Vapor 4 not as bad as it could have been, which was awesome. What did you think about the improvement to Vapor 4, and what do you think was the biggest improvement that came from that?
That's a very good question. So I think Vapor 4 has been a really good release. I think it took a while for all the packages to roll out. I think it was around 6 or 7 months for all the different Vapor dependencies. I mean, we have like 30 odd packages in the Vapor ecosystem, or in the Vapor core team that we are responsible for. So it took a while for all those to come out. So I'm really pleased that everything's been finally tagged and released properly. I think for me, the biggest thing about Vapor 4 is the fact that it's built on top of SwiftNIO 2. So SwiftNIO 1 was out for a while, and by the time the SSWG got together and started building all the different ecosystem packages, SwiftNIO 2 was out. And that introduced things like SwiftLog, Swift Metrics, and kind of all the other things around that. And not being able to use those packages from the ecosystem in Vapor 3 was a bit of a drawback. So you couldn't use SwiftLog, for instance. So now that we can, it opens up the whole ecosystem to the rest of the Vapor community. So if you're building a package on top of SwiftNIO, it means that anyone with Vapor can use it, whereas before they couldn't. And that's a really important thing. I think aside from that, the transition from Vapor 3 to Vapor 4 was handled pretty well. Vapor 2 to Vapor 3 was obviously a massive change because it went from synchronous to asynchronous,
right,
and took a long time for everyone to kind of A, learn how to use it, and B, migrate. And people migrating to Vapor 4 are finding things a lot quicker. I have a very large blogging platform, and it took me a day to port the whole thing over, which I was really pleased with, including all the tests. So being able to see that transition happen relatively quickly is really nice. Vapor's always embraced the latest and greatest of Swift. So when property wrappers came out and we saw what we could do with them in Fluent, it was a relatively easy decision to jump onto it. There's still a few little issues that we can't resolve. There's a proposal out by Tanner and Gwyn, ex-core team and core team, to resolve some of the last few issues. And things like reflection are still really, really slow and hold Fluent back a little bit. So once those things are solved, it can make Fluent really powerful, I think.
Yeah, cool. Let's jump back and talk about some of the new stuff that's going to be coming out with Vapor 5 and all of the new proposals we have in Swift when it comes to async and structured concurrency. How does that sound for you, Tim?
That sounds awesome.
Cool. So we'll talk about that in the next episode. If people want to find you, Tim, where can they find you online?
Twitter is the best place. I am at 0xtim, and that's 0 the number xtim, as if you're writing hex.
Awesome. And people can find me on Twitter at LeoGDion, or my company is Break Digit. If you can take some time and leave a podcast review at Apple Podcast or Google Podcast or Spotify, I'd really appreciate it. And if you have any questions or feedback, feel free to reach out to me on Twitter as well. Look forward to talking more about Vapor and server-side Swift in the next episode. Thank you for joining me, and see you in a little bit.